Hello, and welcome to the Amazon Web Services Partner Webinar Series. Our topic today, Get Closer to the Cloud with Federated Single Sign-On. I'm your host, Maya Kabasi, with the Partner Marketing team here in Seattle. Before I introduce our presenters, I would like to take care of a few housekeeping items. We are recording today's webinar, and while lines are muted, we accept questions anytime during the webcast. We will have some time for questions at the close of the webinar, but feel free to submit your questions throughout the webcast. A copy of today's presentation will be available on demand. We will put the deck on SlideShare and the recording on YouTube. No need to take notes of the URLs. You will receive a follow-up email within a couple of days with the appropriate URLs included. Let's meet our presenters. Mark Diodati, Technical Director, Office of the CTO from Ping Identity, and Ben Brower, Senior Product Manager from Amazon Web Services. On the agenda, overview of AWS Identity Access Management, IAM, how to deploy Ping Identity Federated Single Sign-On on AWS, and we will conclude with a Q&A. Without further delay, let me pass it on to Ben. The stage is yours.
Good morning or good afternoon, everyone. This is Ben Brower. I'm glad to have this opportunity to talk to you today about identity access management from AWS and to introduce Ping Identity and the Ping Federation solution that Mark will be talking about later. What I'd like to do first, though, is give you kind of an overview of AWS IAM and to kind of go through some just very specific fundamentals of what is important about identity and access management and how Ping Federation or Ping Federate it incorporates our solution so that you can federate from the Ping portal into AWS environments. So without a good understanding of identity and access management, where access control is really what it's about, what people are mostly concerned about when it comes to control is that when you have an appropriate access to do appropriate actions, that you want to be able to implement security best practices, of course making sure that you're as secure on-premise as you are in the cloud, and vice versa, and then making sure that you comply with your industry-specific security regulations as you move to the cloud. So if you're familiar with IAM for on-premise solutions or on-premise environments, then you'll be pretty familiar with the IAM concepts within AWS, such as creating and managing users and groups. These basically make it possible to, one, identify who is trying to access the account or the AWS environment, and two, to know what they're capable of doing within the account. Groups will make it easier to manage. Security in the cloud takes it to a new level. This is where you really do need to think about the scale of the cloud, that you'll have multiple users with individual permissions throughout the world trying to access your account in AWS, and ensuring that there's individual security credentials such as access keys, passwords, and MFA, so that you can ensure that the level of security is what you expect. And then, of course, with any sort of service provider, and AWS especially, we need to make sure that security is by default. An interesting thing about identity and access management in AWS is control really is centralized, meaning that you can basically have one user and a username and password that can control all aspects of your environment. So you no longer need different access control systems to manage your VPN, for instance, or manage your servers, or manage your routers, etc. So it makes it much easier and much more simplified to control everything from one place. Another important consideration when it comes to accessing services in the cloud is that You're not just trying to access the services, but you're also trying to access the resources. Therefore, having fine-grained permissions is particularly important because if you're able to access resources in the cloud, such as an EC2 instance or an S3 bucket, then you'll have that much more control over your overall environment. Controlling users' access to APIs in the AWS console is an ongoing consideration, not just from the perspective of the administrator, but also from the developers and others who are trying to write applications within AWS and to access those APIs effectively. And then there's one last very important area around cross-account access, where many customers will have multiple accounts and they will need to be able to access those accounts temporarily or on a short-term basis for a variety of different reasons. So the IAM concepts within AWS make it flexible enough to access those accounts. And then finally, because AWS is a platform on which many different services run and enterprise customers often have a variety of different IAM or third-party identity management solutions, being able to access AWS through a federated environment or a federated model is particularly important, which is what we'll talk more about over the next 35 to 40 minutes. So let's dive a little deeper into the identity management concepts. So as I was mentioning, the users and groups within IAM, AWS IAM, is a familiar concept for most IAM principles. So a user in this case is basically someone who is trying to administer or consume AWS services and resources from the AWS Management Console, such as Bob, who can log into AWS Management Console to administer his company's account. The interesting thing, as I mentioned earlier, is that you could also have backend services such as EC2 or applications that are running on EC2 access other services such as S3 or S3 buckets. This becomes particularly important when you're running applications that require access to these sorts of assets. Groups are basically a way to manage your IAM users easier. So it manages your permissions and basically makes it possible to add IAM users to those groups, which then immediately inherit the policies that you have already created. So for instance, if you have IAM users in a developer's account and you allow them to access EC2 instances tagged with development, but they are not allowed to access EC2 or instances tagged with production. So what this is basically doing is allowing an IAM user to access EC2 instances in one particular development environment, but not allow them to access EC2 instances in the production environment. So identity and access management really answers two questions. Who has access and what can they do? So who has access gets into authentication, where IAM users and groups are the primary tools used to determine authentication. Access policies are basically the ways we go about determining who can do what within those different environments or accounts. So authorization is a particularly important control point that makes it possible for the administrator to determine exactly what a particular user can do once they've been authenticated. We will spend much more time today on the authentication area because when we talk about authentication and federation, what we're really doing is talking about two different use cases. The first use case is how do you access users, or excuse me, how do IAM users access AWS, which is the IAM users in the gold circle. The second one is external users who have been authenticated. These external users have been authenticated by third-party identity management solutions, and therefore what we're trying to do with identity federation is basically allow for both of these use cases to be authenticated and therefore have access to AWS. So what are the benefits of identity federation? Basically, it eliminates the need for managing duplicate user identities. That's probably the most important administration concept. End users do not need to yet need another password to remember. So this makes it that much more easier for users to, one, be able to access not just their one account within AWS, but they would be able to log in to a particular portal, which then would have them have ability to access other services. Leverage your existing investment in identity management solutions is a particularly important concept or consideration that we hear from many of our enterprise customers who have spent a considerable investment in both time and effort and money to build up their identity solutions. And then, of course, you're able to reuse your internal identity management processes, which can be quite cumbersome if you have to redo them all within just the AWS environment. So the last thing I wanted to bring up is the third principle when it comes to AWS and the identity management concepts, and that's called IAM roles. IAM roles basically grants a trusted party temporary access to your AWS environment. So why is this important? Basically what it does is once you have authenticated in some other third-party environment or even within an AWS account that is not owned by you, that trusted party or that trusted relationship basically can be authenticated in your account because it is considered a trusted party. So what it does is, for instance, it would grant access to an identity provider to enable federated users access to the AWS Management Console. This is all done behind the scenes, where we're using a service called a security token service that basically allows the authenticated user a temporary token that lasts up to 60 minutes to grant access to the AWS account. And from there, the IAM role will have specific permissions associated with that particular trust and allow them to do specific things within the AWS account. So just a brief example of how this works. Let's say that you're authenticating with your Active Directory store and that you're using your corporate credentials through your Windows account. So here what you're doing is basically adding your username and password, having that authenticated by Active Directory, and then instead of having to then go to the AWS account or the username and password or sign-in page, you can go directly to the AWS account. It's basically that easy. So with that, I'm going to turn it over to Mark. And Mark, please, let's go a little bit more in detail as to how federation works with Ping Federate.
Ben, thanks so much. AWS provides so many services. It's really an amazing thing. And I'm speaking to the choir, I'm sure, looking at all the folks on the call. It provides what we would consider to be classic SaaS functionality, but also infrastructure as a service and platform as a service. The Amazon AWS folks call this cloud, but I'm going to break it apart a little bit to say a bit about where the market's evolving and the need for third-party identity management services for AWS. When we take a look at the classic cloud usage model for identity today, it's for SaaS apps. It's for employees accessing Workday or Concur for their expenses or Google corporate applications. And so most SaaS applications today of a certain size support some standards within the federation and single sign-on world that really help out with that. But what we're seeing is that the growth of IaaS and PaaS is also driving the need for this. And if you take a look, there are a number of different reasons why this is happening. The number of deployments are growing for IaaS and PaaS have to do with the fact that organizations are becoming more confident that they can deploy stuff in the cloud, that it will run reliably, scalably, that all the promise of elasticity that cloud apps provide is present. The other reason why deployments are increasing, one of those axes, is that there are more services being offered. So as that platform matures, there are more services offered. Therefore, there are more compelling reasons for organizations to go out and adopt those technologies. And on the user side, the other side of this axis, we have more administrators. So take, for example, a typical AWS deployment. Maybe 3, 4, 5 years ago, everyone was running with the AWS root account. Deployments were small. AWS has a very rich set of privilege delegation capability so that you can really drill down and, for example, give an EC2 administrator the ability to just run and start and shut down an instance, but not be able to create one or clone one. And so those capabilities are necessary. Those delegation capabilities are necessary when you look at the explosion of growth for AWS usage. We now have many types of administrators, and therefore we need some way to be able to delegate those privileges. But there's more to this IaaS and PaaS and therefore AWS growth story than just providing IAM services for more administrators. There are more end user services being exposed within AWS. So as an example, S3, Ben talked a little bit about S3 buckets. It's really, for those of you not familiar with it, it's a file storage and distribution service, not unlike Box or Dropbox. And so there are more and more organizations that we see that are deploying those kinds of services. Before we start digging into the specifics, and maybe we'll even take a look at an example of how a third-party identity system can integrate with AWS, I'd like to go over some taxonomy here to make it easier for the folks who aren't necessarily familiar with it. We talked, Ben mentioned the word federation. I'm using it here. Federation is an interoperable technology that provides some services across security domains. In this case, it provides single sign-on. So let's say, for example, a user authenticates to their local Active Directory environment. Maybe the workstation is in a trusted domain, and so therefore they authenticate to their workstation, and we ought to be able to extend out their single sign-on capability across Active Directory to AWS, and that's what Ping Federate and some of our other products do. Federation today in the mainstream is mostly about security assertion markup language. So if you hear people talking about SAML, what they're talking about is a language within XML used to describe how a user was authenticated and who authenticated that user. So you hear SAML a lot. You're also going to hear more about things like OpenID Connect and OAuth, as those things are seeing deployments for sure. So when we look at federation, we have to look at a couple of different components. One of them is the federation identity provider, and its job is to authenticate users, give them those SSO or SAML credentials, and then send them out to an application so they can get logged on. So the user authenticates, and then they have the SAML assertion that travels with them in a web session and gets them into the application. There's another side to federation and SAML, however. It's also the service provider. Now, the service provider's job is not to authenticate users, but to simply take the credentials that are being sent to it from a trusted identity provider and allow that user to log into the session. So a service provider will receive a SAML assertion from a trusted third party that says, I've authenticated this user. Here's some information about that user that might be helpful for you. And then the federation service provider transitions that credential into a local application. Now, what happened in Q4 of last year was that Amazon AWS built in federation service provider capability within the console. So, and we'll go through some specific graphics of this, but this is another example of a service provider. Here I'm showing you in this federation in action slide a very typical kind of federation transaction that happens. You have SaaS applications out in the cloud. In this case, they're hosted. But really, you could have a federated application on premises. You could have an application that's out in the cloud that isn't SaaS-based, perhaps running in EC2, for example. But the bottom line is it's got a federation SP capability, service provider capability built into it, which means that it can accept these SAML credentials and single sign on the user into an application. Now on the bottom of your screen, you see what might be a typical environment, although I would say these days the perimeter for Active Directory and Active Directory joined workstations is starting to drop a bit, but surely this is recognizable by most of you. And here we've got Active Directory as the identity store, and we have users that are authenticating. And what the Federation IDP does here, it functions as something we call an identity bridge. The identity bridge simply takes Identity 1.0 protocols like LDAP and Kerberos and makes them work in an Identity 2.0 world of SaaS. So here users authenticate. They're probably going to get single sign-on because they have Kerberos credentials. And they also have, perhaps in the case of the mobile user, X509 certificates. They'll hit this identity bridge, and then the identity bridge doesn't re-authenticate them again. It simply says, okay, I've validated these credentials you've presented to me. They could be Kerberos, they could be X509. And it says, I'm going to give you your SAML, your single sign-on token, and I'm going to send you right into the SaaS application. And so the user doesn't re-authenticate here at all. And this case, the SAML assertion is passed to the SaaS application. Now here, I'm ignoring some of the other requirements of a typical SaaS app, which would include provisioning, which would happen in a more admin time environment where this authentication is at more runtime. But we'll skip that for now. Here, I've articulated 3 specific use cases that are the intersection of Amazon AWS plus some third-party federation technology. Now, the first one is, as Ben and I have been talking about, is the new capability within Amazon AWS IAM to be a service provider, a federation service provider, which means it accepts those user credentials and it's going to log the user in transparently into the application, and I'll show you that shortly. This is a major step, and as I show you, that it overcomes a huge number of challenges for organizations that have been trying to do this. Handle this explosion of increased users, admins, end users trying to access AWS without managing their credentials and creating users within the IAM subsystem. So that's the new stuff. Now, use cases 2 and 3, for those of you who are familiar with Federation technology, probably this looks familiar to you, in that here we're just simply taking Amazon EC2, which is a way to run virtual servers in the cloud. It's one of my favorite tools ever, actually. And we're installing either a federated IDP, the one that's going to authenticate users and give them credentials and send them on their way to applications, or installing a federated SP within the application as well. And I'll show you some slides for each of these 3 use cases. Before we start looking at those 3 use cases, I think it's important to realize the ways that organizations interface with AWS, because it impacts the way that federation technology works with AWS. Everything within Amazon AWS is about the API. So whether you're accessing Amazon AWS through the web console, where you're performing administration services, or you're accessing S3 buckets, you come through a web-based interface. But you can also access directly through the API or through a command line. What's happening behind the scenes really is that you're getting a set of keys that enable you to do certain things within AWS. They may be service level entitlements. How do I manage things within AWS? It may be resource level entitlements. What can I do? Can I access this S3 bucket, for example? But when you take a look at the fact that Federation is primarily a web-based technology, then what we're showing you is that primarily you'll be accessing these web services through the console. So before Amazon AWS introduced this Federation SP capability, we had saw a lot of organizations rolling their own solution. Just as an FYI, I've been tracking closely AWS and identity for at least 3 years now, back to my days at Gartner when I was a research VP, and so I'm familiar with the technology and the fine folks over at AWS. Here, this was the good old days where if you wanted to provide user level access and you wanted to not create users within AWS, the way you did that, the primary interface mechanisms was through the API or the command line. And you had to write your own code that would take basically curb tickets, and then under the role of an IAM user would go out and grab the necessary federated user keys, the API keys necessary to access AWS service level entitlements or resource level entitlement. It was a proprietary connection. You were really in the business of writing your own here. You were also doing some dangerous things where you were storing not only the keys of that privileged user who could actually get those federated credentials on behalf of those federated users, but you were storing federated user credentials also within this proxy. And while you could do web-based kinds of things through the console, you could make this work with a bit of coding. This was primarily about getting the necessary keys you need and accessing AWS either through the API directly or through a command line. Now, what's occurred since Q4 of 2013 is that Amazon has introduced this Federation Service Provider capability. And now what you can do is you can take a commercial third-party Federation product that's very good at storing keys. You can store those keys in a hardware storage module if you like. That's just basic functionality. And here, this federated IDP is going to authenticate your users transparently. And then they get redirected with the right single sign-on credentials into the AWS console. Now you can do non-web-based interaction. In fact, some folks at reInvent in Las Vegas in Q4 last year showed some of this, where you mimic a browser interaction with a federated IDP, and then you can compartmentalize those credentials and then be able to use them in a say a command line or an API style transaction. But out of the box is primarily about web-based transactions here. Now you notice that we've shifted a lot of the expertise required to do federation back into AWS, where they have the expertise to do this and maintain a single set of code, do all the necessary penetration testing that's required, all of that. So this is a huge and significant leap forward in third-party identity interoperability with AWS. Now you're not in the business of writing code, you're not in the business of storing user keys. It's really simply plug and play, and AWS takes care of the rest for you. So we've talked about security assertion markup language and SAML. AWS requires 3 specific attributes to be placed in this SAML assertion. Remember before we talked about a SAML assertion being something tells me something about who the user is and who has authenticated that user and when that user was authenticated. So here there are 3 attributes that we're going to tell Amazon AWS about who the user is. The first one is something that's expected in every single SAML assertion that is issued. It's part of the standard, and that's the SAML subject name. And here I've taken and created a relatively LDAP-centric view of what that SAML subject name should be, but it can be anything. In fact, many of our clients use a variety of different identity stores to provide federation for. It could be Google, it could be Facebook even, it could be Azure. There's a bunch of different ways this could go. Now the second attribute is the one I think we need to pay the most attention to because I think it's the most interesting. It's basically 2 attributes that are put together with a comma. So if you take a look at the bolded text here, there are 2 attributes that AWS requires to be able to map a user with privilege into the system. The first here is the role of that user. Now in most cases, Amazon AWS does not know anything about this user before they've authenticated. For example, there's no T-Stark within the Amazon or the AWS user store. So we have to tell AWS about what privilege those users should have. And here's a predefined role that says these users can access S3 buckets only. Now the second attribute that's particularly interesting is the role of the federated IDP. And what this means is this role has the privilege to federate users into the system. It's also tied to an X509 certificate. For those folks that are more familiar with federation technology, there's a certificate that's bound to this role also that enables the federated IDP to be able to issue certificates. The last attribute is the role session name. Bearing in mind that in most cases AWS does not know who the user is, we need to tell AWS who the user is. For example, if we wanted to set permissions on S3 buckets, home directories, for example, where we're trying to say only T-Star can access the T-Star S3 bucket, this is the way that you do that. You have to tell AWS the role session name so that if there's a pre-existing set of policies that enable mapping of that user to a specific resource, you can pull that off. We're going to come back to this specific use case in a second with a demonstration, but I want to walk through the final 2 remaining use cases with you. because these are common also, and these pre-exist the new functionality that AWS has added as a federated SP. Here we simply have an EC2 instance, a virtual server that's running a federated IDP. This identity provider is going to authenticate users and it's going to give them credentials, SAML credentials, single sign-on credentials, that an application can natively consume without any coding. And so here it's hosted, obviously. A user is going to authenticate. Perhaps it's a partner of yours. And then they receive these security assertion markup language credentials and are redirected into the SAML application. Now, these diagrams, as some of you familiar with HTTP redirects will notice, doesn't actually show all the HTTP redirects. It's much more simplified, but there's a set of redirects that happens transparently within the Federation protocol to make that work. So this is use case 2. The first one was AWS consuming SAML credentials natively within the console. The second one is running a federated IDP within an EC2 instance. And the third one is running a federated SP within an EC2 instance. And here, users authenticate to this federated IDP, this identity bridge that's on premises. And then they get SAML assertions, single sign-on assertions, that map into an application that's running on EC2. So those are the 3 specific use cases where you can incorporate federation with AWS. I have a few recommendations for you before we actually go into the demonstration. The first is that you really need to understand your AWS access requirements. So for example, if you are good with primarily web-based access, let's say you're doing S3 buckets, or you want to control single sign-on privileges for administrators into the Amazon console to manage service entitlements, then Federation's a great fit for you. Non-web access might be a challenge. It's certainly achievable, and I think over time you'll see Federation solutions that will come and emerge with some of the more token-based technology like OAuth and OpenID Connect be integrated within AWS. One of the things you really don't want to do, and this is just basically good AWS hygiene, is you don't want to be using the AWS super user account for the IDP user, because you've granted too much privilege to that user, and there's a lot of opportunities for abuse for that. And so I think most organizations are fluent in this space. A lot of smaller organizations don't necessarily know this. They typically run with just the root account, but you really need to start delegating privileges, and AWS provides an excellent mechanism for the delegation of privileges here. The other thing you want to do is you want to carefully scope the access rights for your roles. So if I have S3 users, I don't want to give them more access than just access to S3, right? I don't want them, murking around the console and doing some things that might break my applications and therefore, for example, cause service level problems with my partners. So 3 basic sets of recommendations for this. At this point, we're hoping that the demo gods will shine brightly upon us. I'm going to show you a demonstration of how this all works. So in this case, we have users that are authenticating on the lower right-hand side. And on the left side, we've got Ping Federate, which is running in an EC2 instance. So we have a Federation identity provider here. We also are running an LDAP server for maintenance of the user identity. So we'll authenticate the user against LDAP. The reality is, though, that is Ping Federate and its identity management as a service cousin, Ping1, can work with virtually any directory store. It could be Google, Facebook, Azure. It could be a relational database. It could be a flat file even. It's very flexible. But for this case, because I think a lot of you are familiar with LDAP, I'm going to do it that way. And then, of course, we have the user getting single sign-on into that platform. So I'm going to actually walk you through a couple of components on the admin time side to begin the process. Okay. So what we have here is a view of what's happening. We're going to work through the stack from the bottom through the top. So we'll start at the bottom with LDAP, and then we're going to move towards the top where we actually see the interaction with AWS. Here we have a user, Tony Stark, and I've highlighted a couple of fields that are interesting here. The first is that I've created an LDAP object class, a group of users that will support the necessary attributes that AWS wants to know about. And so those are role entitlement and session name. You see them listed here. Take a look at role entitlement attribute here. Notice where the comment is kind of in the middle. The first one, remember these are a concatenation of specific roles. The first one's the role of the user that's going to be allowed into the AWS system. The second one is the role of the identity provider, and we concatenate them here together, and we've put them in the LDAP directory. Now, if you have a fairly static set of roles and you don't need a flexibility on a per user basis, you can store this within Ping Federate and don't have to put it in the LDAP directory. It's not a big deal. Of course, we have role session name, and that's what we have to tell Amazon AWS, have to tell AWS about, so that it understands that this user is coming in, and to bind any kind of policies mapped to the session name to the right user. So that's the bottom layer, that's LDAP. If we take a look, I'm showing you right now the Ping administrative console. I just was logged out apparently. So here, take a look. What we have is much of this data is custom generated when you create the connection, but you can take a look and I'll show you a couple of different attributes that are interesting. The first you see here are the SAML attributes, which are required for AWS. So we're saying within this connection, we need those three. And then I'm going to show you where they come from. They come from the LDAP store. In this case, we're running Unbound ID. Now let's go take a look at what the AWS console looks like. Here, I've logged in. I'm logged in. You'll notice here as the root user. This is a development system. So I've logged in with root privileges. And if we take a look within the IAM subsystem, you'll notice a couple of things. First, let's go look at those roles. The first role is the S3 user role. And if I take a look, you'll notice that this S3 user role maps to the LDAP directory where I'm storing that specific information. But then there's also another role that we need to watch out for too, and that's the Ping identity provider role. Here you'll notice that it's the same one as contained within this LDAP store. See them right here. Now, what I'm going to do now is we've sort of set the way that this is going to work, and then I'm going to log the user in and show you how that works. So right here you have the login window for Ping Federate for a typical user. Now when a user logs on to Ping Federate, they're going to log on just once and will access many applications. So it really is a single sign-on solution. Authenticate once, access many things. Now, in this specific example, we're only going to show AWS, but you get the picture here. It's just authenticating once, and then you'll be able to access the things you need to. So now I'm going to log in as Tony Stark and show you how this works. So now notice now that I've been logged into the Amazon AWS console as Tony Stark. You can see it up here on the right-hand side. And if you take a look, I'm going to try and access some things maybe I shouldn't. You can see here that I simply don't have the privilege to be able to do these things. But if I go to the things I am authorized to access, for example, S3, you'll notice that I can begin to access these services immediately. Let's try this one more time. Oh, there it is. Okay. Patience is a virtue. So you can see here that I've been able to access a set of the S3 bucket specific to me within Amazon AWS. So with that, I'm going to transition. Maya, can we transition back to the slides? Thank you much. So take a look here. I'm going to advance to one more slide. I just want to point out something that's happening in July. We're having our Cloud Identity Summit in July, where we have 4 speakers from AWS coming to speak. The first is Jim Scharf, of course, and Ben, and a few others. The Cloud Identity Summit is the largest identity conference on the planet, and we have at least 110 speakers or so, and we think it's important that AWS be part of the conversation on modern identity. And so we're really happy to have these 4 speakers come share their expertise at Amazon AWS. So at this point, I'm going to transition it back to Maya.
Thank you very much, Mark. And while you were presenting, we got quite a few questions from our audience, and this is the time to answer them. And before we move on, here is the contact information for Ping Identity and AWS. And as we said earlier, the deck will be available on SlideShare, and the recording will be available on YouTube. Within 2 days, you will receive an email with the appropriate URL so you can distribute the webinar or rewatch it if you want to. And let me start a poll, a quick satisfaction poll that will tell us how we did. And if you could just take a few seconds to answer this poll. And in the meantime, this will give a chance to our presenters to go over the questions that came in throughout the webcast.
So Maya, do we want to take these verbally?
So yes, basically, I did assign the questions to each one of you. Ben, I would like to start with Ben, but let's give our audience a few more seconds to complete the poll. All right, let's move on to our Q&A now. Ben, there's a question that came in for you. Would you like to start, and then you can just pass it on to Mark to answer the questions that are relevant to him? Actually, looks like all questions are for Mark here. So, Mark, make your pick. You have about 12 minutes to answer questions. So you can just go down your list.
Okay. So let's take a look at one. The first one is, how do I set up SSO with Ping Federate for multiple AWS accounts? Well, Ping Federate and also Ping One support multiple service providers here. So you could have one AWS instance or one AWS deployment that is a specific service provider, and you could have many more other ones too. And the nice thing about the way that functions for the end user is they can authenticate to Ping Federate, and then they can access all those different AWS domains. So if they're unrelated and aren't managed, that's fine. The user will be able to access all of them. So one of the questions there are a couple of questions on EC2 instances, and so I think this is one of the harder things, certainly for me when I first started looking at this stuff to understand, was that when you look at EC2, you have to realize that that is a machine unto itself. So it has its own set of, for example, it might be running Active Directory. It might have its own Kerberos distribution center, key tickets. It may do a lot of different things. So when you try to talk about strategies for EC2 and federation, you have to look at two specific dimensions. The first dimension is the ability to federate into the AWS console to enable administrators the privileges associated with EC2. So you're kind of administering the outside of the box, where do they have the ability to start up or shut down instances? Can they make new instances and so on? That is something that you could do right off the bat. If you're looking for applications that are running inside the EC2 instance to provide single sign-on onto them, what you typically have is you have either they are SAML aware by themselves, or you can use something like Ping Federate, again, running in a service provider mode inside the EC2 instance, which can take those SAML assertions and transition them into locally understood things. I'll give you an example. Let's say you're running SharePoint and you're running it in an EC2 instance. You now have the ability to, with Ping Federate, inside the EC2 instance, to take the SAML assertion, create WS Fed credentials for SharePoint if that's required. Maybe you have an EC2 instance that's using Kerberos as its primary authentication environment. Ping Federate can also transition SAML into local Kerberos credentials. It can also, for example, if you're running web access management solutions like SiteMinder or others, Ping Federate easily will take SAML credentials and then issue a local token, for example, an SM session ticket, to enable the user to be logged in. So those, when you look at EC2 and thinking about third-party interoperability from an identity perspective, that's really what we're talking about. So there are a bunch there. Let's see what else is here. Can we use a Kerberos token or certificate presented from the premise to Ping Federate, which can be translated to a token understood by AWS? Absolutely. So this is what happens. So Ping Federate running on premises as an identity bridge simply validates those Kerberos credentials or the certificate, authenticates the user in that way, and then it has the ability to issue SAML assertions. Now, SAML assertions are natively consumed by AWS, so this interoperability is just built into our product and other federation products, so that works just transparently when you're accessing the console. If you're trying to access the API directly or the command line, which really have a kind of an API focus, you could do this, but you would have to kind of mimic the browser interaction to get the user's SAML assertion and then wrap that up to present to be able to get access to the API.
Mark, let me jump in for a second. We have a few questions coming in for Ben as well, just to mix it up a little bit and make it exciting. Let me give the microphone to Ben to answer a few questions.
Hi, sorry. There are a couple of extra questions here that I thought I would jump in. One was to ask the question about does fine-grained access policy also access DynamoDB? The answer is yes. There are several different services, AWS services, that do support fine-grained access, of which DynamoDB is one of them. There was another question here about Elastic Beanstalk and when it would support STS and federated services. At this point, I can't go into too much detail on roadmap questions, but I can say that it is certainly one that we're talking about often within the team. There was another question about AWS Direct Connect and AWS Storage Gateway. Does it have full access to AWS? And the answer is yes. You will have full access there. And then let's see, there was one other question I thought would be useful that I could address. It seems that here's a question. Great. This seems great for accessing the AWS console, but is it possible to federate users into EC2 instances, etc., so users can start an operating system, process an EC2 instance without separately accessing, etc.? And the answer is it depends. There is you do need to access or authenticate into the AWS environment of which you can access an EC2 instance, but then you still need to be able to connect to that instance where you'll need to have the credentials in order to actually connect. So there is still a two-step process there.
Back to you, Mark.
I'd like to build upon what Ben's saying in that specific instance, because it looking at the question feed, it definitely is repeated. There are ways to use PingFed to facilitate that login into specific operating system level services or other services that are running within the EC2 instance. So let's say you've got EC2. The easiest use case would be, let's say you have an application that speaks SAML. Well, then there's no other work to do. The user is transitioned in transparently. But if the user requires Kerberos credentials, requires WAM cookies, other credentials, Ping Federate has, I think, about 100 integration kits. They're really agents that take SAML and can make that work. So, as long as things are working within a web context, let's say you have a Windows style server that requires privilege and a Windows user definition, we can transition the SAML credentials from our PingFed or from anybody who speaks SAML. It doesn't have to be our IDP, and we can transition that into a Windows credential so that if they're provided you're working through the web format, we can give you a valid Windows user context to facilitate those operating system style privileges. Another question, does role session name require an IAM user to map to? The answer is no. The user, the reason why role session name exists within the SAML assertion, why AWS created it, is because it wanted to have the ability to be able to set up things like S3 buckets for specific users, even though those users aren't yet defined within the system. So let's say as an admin, I set up some buckets for some users and I set the permissions wildcarded to the specific role session name that's coming in. When that user comes in, Tony Stark, he's going to have access to just his S3 bucket if that's the way the policy is set up. So it's an innovative way to facilitate single sign-on into AWS without that user being an IAM user. It's a federated user in the way that AWS has defined federated users in the past that aren't in the identity store but have some privilege. So it's a neat little trick.
Are there any other questions you would like to address, Mark?
No, I think a lot of these are specific to AWS functionality, and Ben has answered most of those. So I'm open to questions also. If anybody's thinking of them afterwards and want to email us or Maya, I'm happy to answer those too.
Absolutely. And
There was one last question that came in about the timeout session and logout. So when we think about the logout or actually the timeout session, there is a 60-minute timeout for the security token or short-term security token. So if you do log in and authenticate through an IDP, that particular authentication might last for however long the IDP has configured. However, on the short security token service, there is the token itself lasts for 60 minutes, and then you would need to log back in order to access AWS services again.
thank you very much, Ben, and thank you to both presenters for sharing their knowledge about single sign-on and federated single sign-on and joining us today for the Get Closer to the Cloud with Federated Single Sign-On webinar. And to our audience, thank you very much for spending a whole hour with us today. I hope this webinar was useful to you. Before you log out, feel free to check out the registration URL for the upcoming New York Summit. It will be on your screen shortly. And we hope to see you in future webinars. And as I said earlier, you will have access to this webinar on YouTube and SlideShare. You'll have the URLs within a couple of days. Thank you all again and hope to see you soon.